I think we can provide a great gap in taking Kentucky from what once was known as a coal state to a nuclear generation state, bringing our advanced technology to that area.
Welcome back to the Middle Tech Podcast. You've got Logan Jones here, and for this week's episode, we're taking another dive into the nuclear energy space, specifically the role that Kentucky can play in this industry. So we all know that the global energy landscape is shifting really fast right now, driven by artificial intelligence and data center buildouts, advanced manufacturing. They're all driving power demand to levels that we've not seen before. If we want to meet that demand and stay carbon neutral and maintain our energy independence, nuclear has to be part of that equation. And that's where this episode comes in. I got to sit down with the CEO of Global Laser Enrichment, or GLE, Steve Long. And GLE is a company that's planning a multi-billion-dollar nuclear fuel facility to Paducah, Kentucky. What they're doing has national significance. So they're working to onshore one of the most critical pieces of the nuclear supply chain, which is the ability to enrich uranium. And they are using a next-generation technology called laser enrichment. So we talked a lot about what that technology means for the U.S., how it positions Kentucky as a key player in the clean energy economy, and why this project could be an anchor that transitions our state from a coal-powered past to a nuclear-powered future. And then we zoomed out. We got to explore a little bit about how innovation, AI, and energy all connect to a bigger idea, which is human progress. You know, what it really means to keep building, creating, and moving forward as a society, and fundamental truths that make that important. So this is an episode I was really excited to record, and one that is personally one of my favorites. I'm really enjoying kind of digging into the energy space and the role that our state can play in that space. So I really hope you enjoy this one. Before we dive into this conversation with Steve, let's just get a quick word from our sponsors. Before we highlight our sponsors, we'd just like to state that the views and content shared on this platform do not necessarily reflect those of our show sponsors. That being said, Middle Tech is supported by KY Innovation, the Kentucky Cabinet for Economic Development's Office of Entrepreneurship. KY Innovation exists to support and develop Kentucky's startup ecosystem, and we are proud to be supported by an organization whose mission aligns so closely with ours. If you are a founder building in Kentucky, you need to check out the resources that KY Innovation has to offer. You can find more information by clicking the link in our show notes or going to kyinnovation.com. All right, Steve, thanks so much for joining us here. Really excited to dig into global laser enrichment and your all's plans nationwide, but as far as Kentucky is concerned in Paducah. Before we get there, you've got a super interesting and unique background. You're a Naval Academy grad, submarine warfare officer, and nuclear propulsion engineer. Received advanced degrees at MIT and UNC, and now leadership at the helm of GLE. Which is quite a path. So just to kick us off here, if you can kind of walk us through what's the thread that ties all those experiences together and just kind of how they led you to becoming CEO of GLE in 2021.
My schooling is actually aerospace engineering. I'm an aerospace engineer by background. And if you ask how an aerospace engineer ended up on submarines, well, I started out as an undergrad focusing on aerospace systems at the Naval Academy, and then had the unique opportunity to get a master's degree in aerospace, but had already chosen to serve in the submarine warfare community. So I actually worked on the design and guidance of submarine-launched ballistic missiles in grad school. So that's how I married aerospace and submarines together. And then, of course, most of us who served in the nuclear Navy, submarines, and nuclear-powered surface ships, you also, by default, get effectively a nuclear engineering degree. Whether you wanted it or not. And so developed the nuclear background. And of course, when I got out of the nuclear Navy, I joined General Electric and their nuclear business through a leadership program, and spent my first 13, 14 years in the industry with General Electric's nuclear business here in Wilmington, North Carolina. And because of my background and having a clearance from the submarine force, I got involved in a pretty exciting project in my early days at GE. GE had just licensed the technology that we're going to talk about today, the SILEX process, and formed a small company called Global Laser Enrichment. And it was an extremely exciting project. GE was just getting it off the ground, and I got connected with that project and found it to be a really exciting technology. Long story short, Fukushima really impacted the nuclear industry as a whole, and so GE put that project and a number of other nuclear plays on the back burner. And so I went off and did other things in GE's nuclear business, worked in their fuel business, ran their parts business for the OEM fleet of reactors that GE has designed and built, and then did some business development with GE. One of the last things I did was oversee the transaction selling Global Laser Enrichment to its current owners. And again, was probably the most exciting thing that I had ran across in my time in the industry and at GE. And so didn't hesitate at the chance to come back and rebuild the company and take advantage of all the tailwinds that are in nuclear today to make GLE a reality.
Yeah, I mean, speaking of some of the tailwinds, I feel like, at least as far as I've been following nuclear, there's been very few times in history where there's been so much momentum around the space. I know Nima and I got dinner a few weeks ago, and he was kind of talking about his experience in the industry right before kind of the great financial crisis in 2008. There was a good bit of momentum that got cold water thrown on it. But leading up to this, I mean, knowing that you were in aerospace, did you have any sort of interest in nuclear leading up to this, or was it something that you kind of developed an interest in through the Navy and through serving on those nuclear submarines?
Yeah, when I went to school, to be honest, I did not have an interest in nuclear energy. I knew I wanted to serve in the military, and I was really interested. Actually, my study focus was in astronautical engineering, so really the space system side of
Yeah,
aerospace.
yeah.
But as I spent my time in the submarine force, received really exceptional training in the submarine force, and found that I was uh, uh, fairly good at it, at least enjoyed it. And so, yeah, the opportunity coming out of the nuclear Navy to join General Electric, which is obviously a great and really admired company, to learn in that corporation, and really one of the original civilian, commercially focused nuclear powerhouses in the country. It really led the first commercial nuclear reactors going on the grid in the U.S. So that was an opportunity that just made a lot of sense for me, and became pretty passionate about nuclear. And even before um, the current tailwinds, where everyone has sort of really appreciated and recognized the role that nuclear is going to play in decarbonizing, and now on top of that, just sort of geopolitical considerations and energy security for our nation, et cetera. Yeah, I recognized early on that we really had to have nuclear. Nuclear didn't get a fair shot in those early days, especially post Fukushima and in the early 2000s. So I thought GE, even at the time, while nuclear, then the industry was a little bit on the back burner, GE was still trying to make advances in the right places and play some offense. And so there was a lot of exciting opportunity there.
Well, you've kind of mentioned it a few times, GE's role in getting GLE off the ground. And Nemo was kind of giving me some of the history of it as well, with its Australian origins and kind of how this all came to be. So can you just kind of walk us through the origin of the company and the technology, and we'll kind of get into it from there?
Yeah, sure. So the technology that we're commercializing is called the SILEX process. The SILEX stands for separation of isotopes by laser excitation. It was originally conceived by a couple of scientists in the mid 1990s in Australia at a university. And as that technology was demonstrated or conceptualized in the lab, the US identified the technology as potentially disruptive and worked with the Australian government to establish a treaty called the SILEX Treaty, which was signed in 2001, that recognized the potential of the technology, both for peaceful and non-peaceful purposes, and brought it over to the US to be advanced in the US under our safeguards regimes, our non-proliferation controls, and really to help restore US leadership in advanced nuclear technology. If there's going to be disruptive technologies like ours, we want it done here in the US so that we can take advantage of it for commercial reasons and ensure its safeguarding. So that brought the technology over in the early 2000s. As we mentioned already, GE picked up the license for it in the end of 2006, early 2007, and formed the company Global Laser Enrichment to commercialize the technology. It was part of a vertical integration play for GE. GE already designs and produces fuel for light water reactors, had designs for other types of reactors and fuel. And so this made a lot of sense to vertically integrate in the fuel space. And so GE started to construct a test loop there in the late 2000s. and really brought it through to what we call technology readiness level 5, which is a fairly decent scale, coming out of a laboratory scale to what we call a bench scale experiment, and built this unique one-of-a-kind facility called the test loop, which we still operate and run that facility today. It's the only place in the world where you can conduct uranium enrichment using lasers, and we've been doing that for a while now.
Super interesting. And can you kind of walk us through the evolution of enrichment technology? So like you had diffusion, then kind of centrifuge enrichment, and now we're at laser enrichment. Maybe if we can just start at like how enrichment kind of got its start in the first place, and then walk us through the current state of the technology that you guys are commercializing currently. I think that would be a really interesting kind of dive into this side of things.
Yep. So enrichment got its start actually on the non-peaceful side for nuclear weapons, right? And that's really one of the reasons that you see today that most enrichment companies and enrichment technology is started and operated by essentially state-owned or state-backed entities. So it started as a government project, really had its origins in the Manhattan Project in the U.S. here for nuclear weapons purposes. And out of that, as the commercial nuclear industry took hold, obviously we needed lower enriched uranium to run commercial nuclear reactors for electricity generation. So gaseous diffusion was actually the first technology the U.S. deployed for commercial purposes. And actually the Paducah facility, which I'm sure we'll talk about on your podcast here, was one of the first commercial uranium enrichment facilities in the country. It was started to produce enriched uranium for Cold War weapons purposes in the early 50s, and then eventually converted to producing low enriched uranium for commercial purposes. So gaseous diffusion technology is really the first commercial purposed enrichment technology. It did a very good job, but it was extremely inefficient and extremely expensive. In fact, it almost consumed as much electricity as the fuel it produced. So going back now to the Manhattan Project, one of the other technologies that was looked at was gas centrifuge. It was kind of put on the back burner for a while because we had other technologies that could handle more throughput, and that's what we needed for small amounts of weapons purposes. I won't go through the long history of centrifuge technology, but it was essentially brought into commercial scale and operation in the late 70s, and primarily done in Western Europe. And it is the current state of the industry today. So almost all the enriched uranium production in the world comes from gas centrifuge technology, whether it be the two main sources are Russian centrifuge technology and ETC technology, which is basically a British, Dutch, and German conglomerate that developed the gas centrifuge technology that a couple companies in the world run today. Laser enrichment promises to be the third generation of technology. Looking at gas centrifuge compared to gaseous diffusion, gas centrifuge is much more efficient and cost effective, but it moves significantly less mass through a centrifuge than a gaseous diffusion chamber. And so you still need a lot of electricity, not nearly as much as gaseous diffusion, and you need a lot of units in your plant. So you end up having thousands of centrifuges in a plant for any appreciable production. Laser enrichment promises to solve both of the challenges of the previous two enrichment technologies. So first of all, laser enrichment is much more efficient because we are actually specifically targeting the 235 isotope in the uranium, which is the one we want to be enriched for fission purposes. So we're not using mass differences or weights or centrifugal force like in the other technologies. We are using lasers to specifically target and excite the 235 molecule. So it's more efficient. And then also because of things I can't go into here, we are able to produce and move a significantly higher amount of mass through one of our machines versus a gas centrifuge, orders of magnitude larger. And so we need far fewer machines to do it, far fewer stages in an enrichment cascade. So it becomes a simpler, smaller cascade to produce the same amount of material. And both of those translate into lower costs, both significantly lower capital costs and significantly lower operating costs.
And can you talk a little bit about the ability of that process to produce LEU fuel and HALO fuel, and kind of how that plays into the current nuclear energy ecosystem today, and why there's a demand for that in the first place?
Yeah, sure. So I don't know if your listeners are familiar with the enrichment industry in general, but just like a centrifuge, our machines are called separators, and the separator can produce low enriched uranium or high assay low enriched uranium, HALEU as you refer to it. Um, just like a centrifuge, it all comes down to how you orient the process, right? So we put a series of machines in an arrangement that it starts at a feedstock and then enriches the uranium up in 235 isotope through a series of stages, what we call stages in a cascade. And depending on whether you want to produce low enriched uranium, which is roughly 5% enriched, or up to high assay low enriched uranium, which is up to 20%, you simply change the configuration of your cascade and how many stages you have. So it's basically just squeezing an orange. If you want more orange juice out of an orange, you squeeze it harder and harder and harder, right? And so that's basically the same for us. It's just changing the cascade design. Why do we have different flavors, I'll call them, of uranium, enriched uranium? Well, the current light water reactor fleet, which is what the majority of our reactors in the world today operate on and produce electricity from, use low enriched uranium, which is around 5%. A lot of the advanced reactor designs, which are non-light water, so they sodium fast reactors, high temperature gas reactors, they use a enrichments between 15 and 20%. So I think a good analogy for your listeners is like the fuel in your car, right? So uh, uh, stronger engines that rely less on turbocharge and more on natural aspiration, they're fine with lower octane fuels. Whereas if you have a turbocharged engine, you're trying to get more power or horsepower out of a smaller engine, you need a higher octane fuel. And so that's the analogy for reactors and low enriched versus high assay low enriched fuel.
Yeah, that's super interesting. And I think this is a good time to just kind of dive into the current state of the nuclear industry, nuclear energy industry here in America. This is something that I've been digging into in a few different podcasts where we're talking with people in the space. But if you can just kind of help us position where we as a country are in terms of, we've got artificial intelligence that is driving all of this energy demand. We don't necessarily have enough capacity for where we project energy demand going. And so now we're turning to, if we want to both produce the energy that we need and also do it in a very carbon neutral way, or as carbon neutral as we really can, nuclear does appear to be the answer. And so you kind of are seeing artificial intelligence enabling the investment in some of these new technologies. If you can just kind of talk us through what you guys are seeing in the space in terms of, is this some growth that you predict kind of continuing into the future? Is there other things aside from just artificial intelligence proliferation that are kind of driving this? Just kind of help us orient ourselves in terms of where America is in this sort of new energy era.
It's a great question, Logan. You mentioned earlier the financial crash of 2008 and the run up, the hopes of run up of nuclear really prior to that. This time it's very different, and that run up was driven primarily by projections and economic growth and how that would drive the demand for electricity. And of course, first of all, the financial crash of 2008 that really kind of shuttered a lot of major growth for several years. And then of course you had Fukushima, which really put a damper, an unfair damper on nuclear power. This time is different for, I'd say, three reasons. Number one, I think between economic growth and public sentiment, the world is coming to treat and put nuclear in its fair place, its rightful place, as a reliable and clean source of baseload power for carbon-free electricity generation to support all our growth, period. So we've gotten over that public misconception, and I think rightfully so. Second, really precipitated by the Russian invasion of Ukraine several years ago, we have realized as a nation, and I think globally, there's a strong focus on geopolitics and realizing the world is not exactly flat, right? And a big part of geopolitics is energy security. And what we've seen from folks who are not our friends, like Russia and China, is they actually have used nuclear technology as a geopolitical tool to go lever emerging nations. So if you're a country, say in Africa, who needs a lot of power for economic growth, a lot of electricity, the Russians or Chinese can come in and say, hey, we will supply the entire soup to nuts nuclear supply chain for you. We'll design and build your reactor. We'll supply training or operators to operate it. We'll supply the fuel. We'll sell you all the parts. And they basically provide the entire turnkey operation to countries that they want to lever. And so we, as the US and our allies, really have taken a step back from nuclear or from exporting energy technology in general in that regard, and therefore have lost a lot of leverage in achieving our goals globally. So the U.S. in particular has realized the importance of having a strong, specifically nuclear supply chain in all aspects of it, and being a net exporter of nuclear technology as well as other, societal enabling technologies. And so that's number two. And then number three, as you started off the question with, is absolutely artificial intelligence. So the carbon-free electricity generation was kind of the baseline, the bottom of the plan. What we didn't anticipate a couple years ago was the geopolitical change of dynamics as fast as it changed. And then, of course, really the explosion has been artificial intelligence and the demand for the power that those data centers consume. And I see different figures all the time about how much power a data center needs and what the total expected growth is, but it's measured in tens, if not hundreds of gigawatts over decades, right? And so the only way to get there, really, if you prioritize reliability, clean, carbon-free electricity, is with nuclear. And so obviously most of the folks, the hyperscalers who are looking to go into artificial intelligence or looking to make it the core of their business model, the Microsofts, the Googles, the Amazons, et cetera, they all recognize that they want their electricity to be carbon free. And so that's why nuclear is such a good fit for those folks. And it's why it's really what's driving a lot of the acceleration, driving the valuations of companies, all the interest in nuclear, et cetera.
Yeah. Yeah. It's a super interesting dynamic how, because we're at least speculating that we're going to see a pretty large economic return from artificial intelligence in a way that's kind of backing into making nuclear a little bit more investable because we have so much demand for the energy that it's going to produce. It's like, okay, well, now we can kind of have it makes sense to invest in it. I'd like to focus just from the nature of this conversation on a part of the supply chain, which is the fuel, which you guys are dealing directly in. Can you kind of give us your perspective on where the global market is for that currently and where that fits into America's fleet of reactors? So are we currently getting our fuel from other nations? How much of it is coming from America ourselves? Is that a risk that you see for this kind of build out of nuclear? Can you kind of give us your position on that and how our audience should be thinking of those topics?
Yeah, it's a great question, Logan. So maybe to start with a brief background on the fuel supply chain, to get from the mineral uranium that's in the earth to a reactor, there's essentially four major steps. First, the uranium is mined out of the earth. It comes out of the earth as an ore. It's then converted into a gas, which is for purposes of enrichment, and that gas is called uranium hexafluoride. So when you talk about conversion, that's done at only one facility in the U.S., and that's Metropolis, which is right across the river in Illinois from Paducah, Kentucky. So it's turned into uranium hexafluoride there. It's then sent to an enrichment facility where it's stepped up in 235 isotopes from where it comes out of the ground natural at roughly 0.7% of all the molecules are 235s. And then as it leaves the enrichment stage today, as we talked about earlier, it's roughly 5% enrichment. And then it goes on to a fuel fabricator. We've got a couple of fuel fabrication facilities in the U.S. GE's one of them here in Wilmington, North Carolina, Westinghouse in Columbia, South Carolina, and Framatome in Richland, Washington. And that there it's converted back to a uranium oxide and then put into ceramics and loaded into a fuel bundle to go into a reactor. So back to enrichment now, the U.S. demand for enrichment to fuel all the reactors in the U.S. is roughly 15 million SWU. And none of it is supplied by U.S.-owned companies today, and only one U.S. facility in the U.S. So there's one facility called Urenco USA. It's in Hobbs, Mexico, and it supplies roughly 5 million SWU, so about 30% of the market. The rest of the market comes from foreign sources, whether it be in Western Europe, But in terms of the countries that are not our friends, Russia has historically supplied between 20 and 30% of the enrichment demands for the U.S. That is tapering off. The Biden administration enacted a Russian import ban in 2024, which is phasing out Russian imports through 2027. And then roughly, again, the numbers vary, but between 10 and 20% is coming in from Chinese sources, and China expects to grow the sources or to grow its enrichment supply worldwide substantially in the next decade. So today, all U.S. utilities get their enrichment from uh, non-U.S. companies, and specifically, majority of it from non-U.S. sources.
And so when we think about energy independence, we really kind of have to think about it as all of these different pieces of the supply chain. How can we kind of fortify those within our own nation? And so that's kind of where, when we see companies like GLE coming into Paducah and people in the state of Kentucky are wondering, okay, well, there seems to be a lot of attention around nuclear. What role can our state kind of play in this ecosystem? That's a very critical piece of this supply chain that you guys are kind of servicing. So I'd really like to just kind of transition the conversation to talking more about your all's plans in Paducah, what's been proposed, the investment that would be made there, why that was chosen, all of those sorts of things. So let's just kind of start off by diving into the history behind Paducah and that gaseous diffusion plant. We don't have to get super deep into this, but I think it would just be helpful for listeners to understand why this site, the history behind it and why it was chosen to kind of kick off the conversation around what's looking to be done there.
So to start with, why we chose the Paducah facility. So we have an exclusive agreement with the Department of Energy's Office of Environmental Management to take the decades worth of what we call tails, which are essentially the secondary stream of depleted uranium. When you enrich uranium, you put feed into an enrichment facility, you get an enriched product stream out and a depleted tail stream out. And so as the Paducah Gaseous Diffusion Facility operated for several decades, they took all the tailings, which were depleted in uranium, and stored them on site there. And so there's roughly 200,000 metric tons worth of depleted uranium on that site that's still at an assay that's high enough to be worthwhile to re-enrich for us. And we have a unique capability to do that because our process is more economical. We can more economically address those tails and bring them back to an enrichment like a natural assay that we can then sell back into that fuel supply chain we talked about earlier. So that was really the impetus of looking at Paducah first and foremost was, hey, you have one of the world's largest uranium mines above ground there, sitting on the cylinder pads there on the legacy gaseous diffusion facility. As we got into looking at site selection and the demographics around Paducah, first of all, because of its rich uranium enrichment history, you've got a lot of families there who grew up through generations in the enrichment industry and specifically working with uranium hexafluoride and that medium. And so you have a workforce that really has it in their genetics, right, to work around the materials that we need to process. On top of that, Kentucky as a whole, and Western Kentucky in particular, is a very hardworking, famous blue collar state and making a lot of investments and transitioning in advanced technology. And so I think we can provide a great gap in taking Kentucky from what once was known as a coal state to a nuclear generation state, bringing our advanced technology to that area. So in November of last year, we purchased approximately 690 acres of greenfield site right to the southeast corner of the gaseous diffusion facility. So we're right next to those cylinder yards. And really, by siting our plant there in Paducah, we offer a single site solution. So we're going to pick up those cylinders and that depleted uranium right from the gaseous diffusion facility. We're going to transport it right across the fence line to our facility, bring it into our facility, re-enrich it back to natural or higher, and then sell it into the market. We started originally as our baseline plan to take those tails and produce natural uranium equivalent out of them. And so we would sell that into that segment of the market, and then, of course, build on more capacity as we go. As the market continues to evolve and looking at incentives the U.S. government is offering and others, We're looking at reprioritizing those capacities and potentially deploying low enriched capacity at the same time or sooner than our natural uranium capacity. But regardless, our goal is to really have that plant in operation by 2030 at the latest. And that's really built around what we see as natural supply demand fundamentals in the market, regardless of what happens elsewhere, whether it be US government incentives or otherwise. And when we construct and operate that facility, it's going to be a multi-billion-dollar investment. We've submitted our license application for that facility, which will allow us to produce up to 2,000 metric tons a year of natural uranium and up to 6 million SWU of low enriched uranium. And those are SWU stands for separative work units, which is basically a measure of enrichment capacity. So it's a pretty appreciable sized plant. We anticipate over 1,000 construction jobs during full construction of the site. We're going to develop roughly 190 acres of that 690 acres I told you about. At full build out, we'd have roughly 1 million square feet under roof for the process. And we plan to employ long-term between 300 and 400 jobs, obviously depending on how much capacity we build out over time.
We'd like to take a quick break to highlight one of the sponsors of the Middle Tech podcast, Awesome Inc., the innovation hub in Central and Southern Kentucky. Awesome Inc. helps grow the Kentucky tech and entrepreneurial community through pitch competitions, a mentor-driven startup accelerator, the Kentucky Entrepreneur Hall of Fame, co-working, and the Team Alpha internships. Be awesome. Now, back to the show. And can you kind of help us frame the 200,000 metric tons of the tails that are currently there? Are you guys looking at that as this is part of like the DOE's loan program to go and kind of re-enrich those tails, and that's just like kickstarting the investment that you guys are making in Paducah, and then once you guys have gotten through those, then it kind of turns into you're running kind of business as usual after those tails are re-enriched? Or how, I guess another question is like, how long would it take you guys to re-enrich all the tails that are currently there, and kind of how should we be thinking of that?
Yeah, great questions. I'll answer the last question first. So at our planned capacity of roughly 2,000 metric tons of production a year, it would take us roughly 35 years to work through that 200,000 metric tons of feed. You asked if it was a Kickstarter. You could call it that. I would characterize it more as sort of the foot in the door. Again, before the significant turn of events with the geopolitical factors and now AI, right? We were looking at, hey, what are the market opportunities that exist regardless of whether these other factors happen to pivot towards other types of production? And because of some of the post-Fukushima downturn that happened in the 2010 timeframe, not a large investment was put into uranium mining and conversion, right? So today, even with all this talk about enrichment, we see a bottleneck specifically in uranium conversion in the Western world, and not a lot of new mines have come on. So the opportunity to take that uranium mine there in Paducah and turn it into usable material again, take what is going to be otherwise a DOE disposed of waste and turn it back into an asset for clean electricity is an opportunity that exists for us, like, no matter what else happens, right? And so when you're commercializing a technology like ours, when you're a privately run and privately funded company going up against state-owned entities and state-backed entities, you want a baseline opportunity that is sort of insulated from all those other things, right? And so securing that agreement with DOE, we're actually going to purchase those tails and re-enrich them and sell them. We're not getting any cost share from DOE or otherwise in that regard. But having the right to tap those tails and use them as a feedstock and then sell into the natural uranium market is an opportunity that exists and is our baseline plan, no matter what else happens.
Very interesting. Okay, so the DOE loan, I believe is it 1.5 billion? That is kind of that's the program you guys have applied for.
Yeah, it's actually more like a grant than a loan, and DOE has
gotcha.
Roughly 2.7 billion.
Okay, all right. And just what, I guess, to high level, help us understand why that was put out in the first place by the DOE. Kind of what was the purpose of that side of things, and tell us a little bit about how that played into your all's decision as well. I know we've kind of hovered around that, but just to dig into that a little bit more.
Yeah, sure. So the funding most of the funding came from the Nuclear Fuel Security Act, which is really focused on restoring U.S. leadership in nuclear fuel supply. And again, that falls mainly out of the geopolitics. So the U.S. recognized, hey, we have essentially we have no U.S. facilities and we've fallen behind in enrichment technology. And so the U.S. government is incentivized via what is essentially a grant program. They've really prioritized the production of low enriched uranium to get folks like us and others to produce or provide new sources of low enriched uranium supply in the U.S. Um, the way we see that is sort of an accelerant, right? So our baseline plan, like I said, exists regardless of what happens and whether that money comes to us or others. But with this kind of grant support, it essentially for folks like us trying to enter the market, it helps us de-risk the capital and de-risk the project of deploying a facility, the first of a kind in a space like ours. And so if we're an awardee into that program, and so far DOE has said they plan to make at least one $900 million award, possibly two for low enriched uranium. I think obviously we'll all see in the end what the final awards are, but we would use that to accelerate our plans and pull our commercial dates forward if possible, and then also look at reprioritizing or reproducing the first modules we put online. Are they going to produce low enriched uranium first or natural uranium? And obviously, with the incentives as DOE has offered, we would focus on low enriched uranium.
Okay, very cool. As a state, as Kentuckians, and we're kind of looking at where things are heading, and we're wondering, how can we as a state ensure that, we can play a role in this new nuclear build out? We've got, now GLE, we've got kind of this attention coming on us again around enrichment. As a state, if we kind of project out, if we get those assets in place, what kind of role does that set us up to play in the future? What other types of industries should we be considering to kind of that are tangential to that? As a CEO of a company that's coming in here that has kind of the knowledge of the space, what do you think we should be paying attention to in the future?
Yeah, excellent question. We have long viewed GLE and Paducah as sort of the anchor tenant in what can become a campus or an ecosystem around the repurposing of that gaseous diffusion site, as well as the economic growth of the state statewide, and not just in Western Kentucky, right? So when a plant like ours is sited in that area, if you just take the supply chain that really doesn't even touch uranium or radioactive materials, we're going to need folks who produce lots of engineered components, right? Obviously, we're going to need a trained and skilled workforce, both in terms of working with uranium hexafluoride, but also for us, there's laser technicians and laser technology, and then folks who have skills in things like mechatronics, which is the combination of equipment and controls, advanced manufacturing, high quality manufacturing. And that's another thing that the U.S. really kind of let go. When I think about the future of the U.S., we got really distracted by focusing on exciting things like Facebook and stopped solving really hard problems and producing really high quality stuff, or at least being a leader in it, right? And so what excites me about bringing nuclear back to the U.S. and making us a forerunner in it is that it's when you think of nuclear, you think of uranium and reactors and that sort of the house. But along with nuclear comes a huge supply chain of making real things, right? Making hardware. And so we, along with a campus in that area in Kentucky, I think Kentucky can focus a lot on restoring the U.S. manufacturing and specifically advanced manufacturing, making high precision engineered equipment with quality, reliability, not cheap stuff, we're not bending sheet metal here. We're making real hardware. So I think that's first and foremost. And then, Kentucky finds itself very near, really in the middle of a region in the U.S. that's extremely pro-nuclear, right? And so as the advanced nuclear or just the growth of nuclear in general, whether it's small modular reactors that operate on light water technology or the advanced designs, they're all going to bring along growth in the supply chain as well. And again, it's going to be on the equipment side, And it's also going to be needs for additional conversion facilities and deconversion facilities and fuel fabrication facilities. And so, what you find especially when you get into handling uranium and the fuel materials, you want to site your facilities in areas of the country where there's already an ecosystem like that. And so Paducah in particular has the opportunity to build that ecosystem. You've got Metropolis across the river there that already is the US's sole conversion facility. GLE will be a significant scale enrichment facility there in the area. And so it would start to make a lot more sense for others who are looking at siting some of those other facilities adjacent in the supply chain to bring their facilities and reap the benefits of a workforce that's already trained and skilled.
Yeah, that's something I'm really trying to just uncover and really understand as I do these sorts of interviews. Is we definitely, we have a history being an energy state in the first place through coal. Yeah. We have a trained workforce that wants to work hard. We have kind of the Southeast Commerce Corridor where we have kind of the logistical hubs that we need, and we have the manufacturing base, at least to get us kickstarted, going in the right direction. I feel like that the vibe of the entire country has kind of shifted to where now we're taking it a lot more seriously to think about what it means to produce things in our country again and produce high quality things. Absolutely. And it's just something that it seems like this area of the country is so well positioned to ride that wave. And that's really a lot of the reason that I want to create this content is like, I just want people to pay attention to it. And then I hope that attention leads to investment and leads to policy and all of those sorts of things. And that's really what kind of gets me excited when I see companies like GLE come and want to invest in our state is, that's just really a Kickstarter for a lot of other economic development that can kind of happen in our state. And, that's the other piece of this I kind of wanted to discuss with you is the economic development side of this. You mentioned, 300 to 400 jobs, around 1,000 construction jobs to actually build it. Can you talk a little bit about, I mentioned it there, we were a coal state. Talk just about like workforce transition. How much training is required to get people kind of ready to work in the nuclear industry? We already do, of course, have a history being involved in enrichment, but how much of a task is it to get our workforce kind of geared up and ready to work in this industry?
Great question. And one of the things that I didn't hear you mention specifically in your comment there, but we've observed in Kentucky is that you have a great university and education system that's partnered
Absolutely.
with industry. I worked with several states in my time at G, and I think Kentucky's doing a fantastic job from the university program all the way down to the community colleges, and specifically in Western Kentucky, how they've partnered with folks to develop the workforce. So looking at our company in particular in that region, I'll say that it's fairly easy to set up a workforce training program in terms of a certificate program or a 2-year vocational program. What's hard is to build the safety culture that we want in the nuclear industry, right? Our process is relatively safe. We're not operating a nuclear reactor. There aren't significant risks associated that the public gets worked up about sometimes when misconceptions are spread. But it's still, nuclear is special and unique, right? And so one of the biggest challenges when you're trying to build a workforce in a new area is to instill that nuclear safety culture. And so Paducah specifically already has that going for them, right? You've got, like I said, families and generations who have worked in that industry, who understand the basic principles of a safe nuclear safety culture. So we have that foundation to build on. And then, of course, we're already starting to work with the local university system there. Our programs for operators will focus mainly on 2-year vocational programs, specifically in nuclear operations. So taking mechanical type roles, operating valves and plant process equipment, but with a nuclear safety and operation and quality background. And then we've been working with the University of Kentucky system to develop a laser technology program. So we've had great success working with a couple of community colleges in the country who have laser technology programs. These programs typically produce laser technicians for industries like manufacturing, where you're using additive laser lithography or laser welding and cutting. Those basic skill sets and fundamentals apply one for one with our laser technology. And so we basically report programs like that into Western Kentucky and use those as feeder programs for our highest skilled operators. And then, of course, what I mentioned earlier, I think mechatronics, especially with pharmaceuticals, and other adjacent industries like that have become pretty predominant programs in the U.S. and those types of skill sets are useful in an advanced process like ours as well. So to answer your question, we started working with the Enrichment system already to obtain grant funding to build those workforce development programs. And we will use a mix of folks from our headquarters here who are seasoned operators uh, to essentially train and build a workforce there in Kentucky with feeders from the local community to build our workforce over time.
Yep. That's awesome. And I'm glad to hear you say, and I'm sure anybody listening is glad to hear the focus being placed on a culture of safety. And I was fortunate enough to go and do a tour of the Sequoia nuclear plant down near Chattanooga with the TVA. And that was probably my main takeaway from walking through an active nuclear facility is just the safety culture is phenomenal. And it's really something to witness that I wish everyone that has any doubts about nuclear could go and experience firsthand for themselves. I made a comment after that. It's like, if you have any doubts about nuclear safety, you need to go and tour a nuclear plant. It's like, obviously not everyone's going to be able to do that. But I just think we as Kentuckians, I think one of the things that we really take pride in is like the natural beauty of our state. I think that's one of our biggest assets in the state, aside from some of the other things that we've mentioned here. And I think one of the first things that you'll hear people say when they hear about nuclear kind of coming into the state is, well, I don't want to have any environmental risk around nuclear. So just what would you say to those people who kind of have those concerns that they're brand new to nuclear? They might not have done kind of the prior research to understand how this technology works or where the risks truly are, but just kind of put their minds at ease a little bit around where the safety risks actually are and how those are being mitigated, and the truly just the safety of this space as a whole.
Yeah, well, specifically for GLE and our technology, our enrichment process is a very clean process from a nuclear standpoint, right? We're not using any significant chemicals in the process to do any, we're not working with solvents or, there's hazardous liquids, things like that. So yes, we work with uranium hexafluoride, which is it's a gas, it's a solid, it's essentially a chemical substance. But we go through a rigorous licensing and safety analysis process, so we ensure that we protect and make sure that UF6 remains in the equipment and in the approved cylinders. And there's a very good track record in the industry as a whole, and with our company as well, of meeting those high safety standards to make sure that not just the public but our own workers are safe. And we have a very low incident. Our expectation is no worker gets injured by working with uranium hexafluoride. Outside of that, we don't expect to leave any significant environmental footprint. Obviously, we're going to clear the site and develop the site, but we see ourselves as actually helping to clean up legacy waste on the DOE side, right? We've got those tails there at Paducah that the DOE is disposing of over time. We help the DOE reduce the total volume that it has to dispose of and bury. We also help the DOE accelerate their cleanup mission by taking a significant amount of material out of the cleanup process and putting it back into use, right? And as for electricity generation. So in terms of bringing new hazards to the area, we don't bring any new hazards to the area. We're bringing a very clean and safe process. Our process has already been reviewed and approved by the NRC once, and we're going through it again here specifically in Paducah, and expect to be successful again. So bottom line, I think we bring a very clean operation to support clean electricity generation from nuclear.
Absolutely. Well, for this last part here, as we kind of wrap things up, I want to zoom out a little bit and really almost take kind of more of a philosophical look at where all this progress is leading. So one of my kind of core things that, I really try and view as a lens for all of this is, how does this lead to human flourishing? And so if we zoom out and we think of some of these narratives that we hear, you hear things like degrowth, we need to consume less electricity, we need to consume less as a species. I really just, I don't like that narrative. I think a lot of people don't like that narrative, and I think rightfully so. But just to dig into kind of why, I just wanted to kind of get your opinions on the law of the universe is entropy, right? Things move from from order to
Yeah.
disorder. And that is a fundamental truth of the universe. So stasis as a species is not an option. We kind of constantly have to be pursuing progress and growing, whether that's the population, whether that's, just innovation. And so that's really kind of the truth that I pin a lot of this to, is like, I think just the narratives around artificial intelligence and energy production and consumption right now. It's like, well, why do we need all this? Like, why do we have to pursue all of this in the first place at all? And really, what I try and kind of pin that to is human progress is kind of an inevitability. And human progress is the way that we fight against that entropy that is the law of the universe. Like, eventually, if we're not progressing, the universe is going to move from order to disorder, and the species ceases to exist, theoretically. So I just kind of say that as a way to try and frame this entire space when people are like, well, why can't we just be happy with what we've got? Why do we have to keep trying to pursue growth and kind of further this and invest in all of this innovation and everything? I don't necessarily have a solid question around that. I'm just curious how you kind of view that entire thing. I know it's a really big sort of topic there, but I feel like that's a good place to kind of end things and try and frame it for everyone,
Yeah, no, all great thoughts, Logan. And, look, I would say it this way. One of the reasons that I was excited to join Geely and be a part of it is, first of all, born in the U.S., a patriot, believed in the strength of our nation, want to see the U.S. lead in advanced technology, and especially technologies that are important for global reasons. Everything from quality of life, in terms of powering economic growth. And I'm not even talking like powering AI. I'm talking about powering fundamentals like clean water and electricity for, basic life needs, right? And that's a significant issue that people in third world countries or emerging countries have a real challenge, right? They're not worried about, can I Google something on Chat GPT? And again, going back to just the story of U.S. leadership in that, I wanted to work on something significant. I saw an opportunity with GLE to do that in the U.S. here, and that's what's attracted me. I think I believe in a couple things. First of all, a rising tide lifts all boats, right? And so I think as we invest in these areas of advanced technologies, look at AI or nuclear, with both of these, we have to be safe, right? Nuclear is special and unique, and so we treat it special and unique, and we make sure it's very safe. With AI, you can spend a whole dozen podcasts on all the rabbit holes you can go down on which way AI goes. But I think everybody agrees you need some controls around AI to keep it in the box, so to speak, and use it for good purposes, noble purposes. But if you want better results for mankind, for humankind, the best answer is not to do nothing, right? If you want different results, you need to do something different. And so I think with the right controls in place, all the advancements we're working on, again, nuclear, which provides clean and reliable base electricity, and we all need energy and electricity to make our societies better. We need it we do need these technologies to consume less electricity, right? As we advance engineering, as we push the state of the art in these technology areas, we learn how to make things more efficient, how to use less power, how to use less materials, how to potentially reuse materials, things like that. So ironically, the arguments against advancing society because we don't want to consume anymore actually prohibit us from getting more efficient at consuming what we do need to consume. So for all those reasons, I think, again, advancement with the right controls, with the right oversight, and for the best and most noble purposes is a worthy cause. And again, in a microcosm, that's why I'm here at GLE. I want to see the U.S. as a leader in advanced nuclear technology. I think it helps our workforce and it helps our nation position globally to achieve good outcomes for mankind.
Yeah, I love that. I love that tie back into GLE. And, I just feel like at the highest level, I'm trying to kind of bring that narrative into the conversation as well, because at the highest level, that kind of determines where a lot of people, how they view a lot of what's going on in society right now. So I appreciate your thoughts on that. But as we wrap up here, Steve, I just want to say, thank you for taking the time to join, and thank you for making the investment in Kentucky. We're excited to watch you guys grow here and support you any way that we can. So Yeah, it's been great having a conversation here, and we'll be following along closely as you guys develop the Paducah facility.
Thanks, Logan. I really appreciated the conversation. It's great to be on the show.
And then one last thing before we let you go, we always like letting our guests kind of plug where people can keep up with them. So whether that's you personally or GLE as a whole, websites, LinkedIn, newsletters, anything like that you kind of want to point people to as a resource, please do so.
Yeah, sure. So our website is www.gle-us.com. And we post a lot of our news updates there as well as on LinkedIn. Next thing to look forward to here, we're continuing to make great progress on scaling our technology at our test loop here in Wilmington. And that license application I mentioned, which is a real key to constructing the safety related portions of the facility. We expect to have that at the end of 2026, early 2027. So lots of exciting news here coming in the next 12, 15 months.